Okay, so we are now investigating Shift Cipher or Caesar Cipher. So the concept is quite simple. This is one of the most basic encryption, and the concept is that you have the key and you have your message in the blue one, and then you have the key in orange, and then the key, all you need to do is just move it around. So I just have to copy the key into two because I will show you in 1 second. So let's just say here we are going to shift these characters by 5, right? So that means we're gonna shift in. So from A point here, we're gonna shift it by 5. So we go 1, 2, 4, 5. Nope, wrong way, wrong way. We want to shift A by 5, so we go actually shift left. So confusing you guys. Let me just add a character in there. 6, 7, 8, 9, 14, 15, 17, 18. Why I use 0? Because we're sort of thinking about arrays as well, and you'll understand shortly. So we're shifting A by 5. So A by 5 basically means we're going to F. So we're coming to. So A, we're shifting A to 5. And now we're missing characters here, so we have to add extra characters at the back. So adding it here, right? So that one there will be 6, 7, 28, 29. So that is, we're shifting it by 5. So now, once we align this, then we can easily translate this. So we can do H. So H is now M. E is now J. L is now Q. Then O is now 19. So T. And then your XYZ, it's now becoming C. Well, that's easy if you have a key. But for to do that in the computer, it will be very challenging. So how are we doing it? So the way that we need to do it is that we need to know the index of the letters. So let's say we start with H, right? H, the index of H is 7. So we go 7, right? So let's just do A equals index of H, which is then will give us 7. Okay, so that means A is now equal 7, right? And then now we want to do the new character, V. So no, not A. Let's just do message. And then we have encrypted here. Oh, we go encryption equals 7 plus 5 because we're moving it by 5, right? So that means it's now equals 12. Okay. So now we go to the encrypted message equals character at index 12, which will give us, so if we go back still here, index 12, that will give us M. So that is good, right? So now we have a problem on the XYZ. So let's copy, let's create another text area here. Now we have the message basically equals to index of x, right? So which will give us 23, right? So our integer representation of x is 23. So now the encrypted means we have to do 23 plus 5, which then equals to 28. Now we do have a problem here because our numbers here is actually only hit 25. So that's a problem, right? So that's a challenge. So what we need to do in here is that we need to figure out if we're counting here. So we're counting here, this one here. So after 25, this is 26, but that's not right. What's supposed to be? It's supposed to be 0, 1, 2, 3, 4, right? So what we need to do here is that we need to minus this 28. So the new E, we need to do 28 minus 26, which will give us uh, 2. Yeah, 2. 28 minus 26 will give us number 2, which means we go back to the index here. We go 0, 1, and 2, or 0, 1, and 2, which then means that the E message character at 2, which will give us the letter C. So that's the mathematical calculation, right? Now, there is a problem as well because now we need to figure out is that sometimes the numbers is gonna be less than 26, sometimes the number is more than 26. So to handle that problem, we have a mathematical operations called modulus, or sometimes it's represented with the number percentage. And what this is doing is that this one will give you the remainder of a division. So 12 modulus 26, that one will equal 0 because there is no remainder. You can't divide it. And you have 28 modulus 26. It will give you a remainder of 2 because 28 divided by 26, you have 1. So 28 minus 26, you have 2. So that's how it's calculated. So that is how you can do the cipher calculations. Now, in computer sense, we do have what we call an ASCII table. So all the characters is represented by a number. So all characters has a number associated with it, and then you have 65 for capital. This is the character for the capitalization, right? So you can hard code that one, or we can just use the character to figure it out. So we have to remember that in the normal table, A is a 0, whilst in here A is 65. So in calculations, we have to sort of normalize this as well, right? So let's figure out. So how are we gonna do this? So first of all, we need to read the character, we need to read the message, and what we want to do is that we need to process its character. Uh, but before that, we have to make sure that convert the message to capital letters. Process its character, shift the character, and then um, get the new character. So that's how we're gonna do it. Okay, so let's try to see if we can do some pseudocode on it. So what we can do in here is that let's try this. So let's do set a, it's a equals. Now this is the command that you can use to get the ASCII, and then you do a. So what this one will do, this one will give us 65, right? And then you go read message. So you can do a get message from user. And then what we can do is we can do message equals message dot to uppercase. So we can do that one atau, or we can just say convert type message text to uppercase. So this one here, if the user enter like this one here will be, so that's how we want to do it, because we can only work with one or the other, right? And then we can do for each character in message. So we can do that one, or we can do for I equals 0, we can play with the index to message dot length -1. Next. That character equals message. We can treat like an array, so we can do message I. So this one here, read a character. And then we can do set character index equals ASCII. So this one here, reads a character, for example, H. And then this one here will get us our ASCII characters of H, which is 72. Right? So now we're gonna do set new char index, or we can do encryption index, which is equals to, we want to do what we want to do is that we want to move it. But remember, this is the index is based on index A 65. So what we can do is that we can do char index minus index A. So this one will get our character back into the index 0. 72 minus 65, that one will give you 72 minus 65. My brain doesn't work. So that one will give you 7. Right? And then after we do that one, we then add your, we need to add the cipher. So we need to get the cipher. So we go get, let me just delete that so I can bring it up. We need to read the shift. So get shift from user. So this one here, let's just say the users want to shift by 5. So now we go that one, and then we get plus the shift. So now that not shift. So that one will do 7 plus 5. So that one will give you 12. And then what we want to do is we want to do a protection, because we want to protect it so that if it goes more than um, goes more than 26, we want to divide it by 26. So let's have a look. Okay, so we want to do this, and then we want to do a full protection, and then we want to do mode 26. So what this will do here, let's see, I got too many brackets, but it's fine. So we want to do here, if we are more than 26, so let's just say we get into like 28, by applying mode 26, then we only gonna get 2. So that's what we want to do. And then once we've done that, we just have to put one more bracket. Just be careful with brackets as well, because that's gonna be a problem. And once we calculated the new index, we need to add back our index A. So we go plus index A. So that way, in here we got 72 minus 65 equals 7. 7 plus 5 equals 12. 12 mods 26 equals 12 mods 26. We cannot divide it, so we still end up with 12. And then 12 plus index A, 65, that one will become 77. So now we need to do, we need to set encrypted message. We just have to do a blank string here, and then we add the message. So encrypted, set encrypted message equals encrypted message plus uh, character. So we do a character. Okay, sorry, it's trying to find. There is no command here, so we're just going to do character of encrypted index. Encrypted, be careful of the name. So this one here then will give us, originally H is 5, so 77 will become 12, M. So that will give us M. So, and then it's just gonna keep building up. So it's gonna go M, and then it's gonna add J. So once we look through the characters, it's gonna have N, J, L, L, something like that. So that's how it works. Now, what we need in here as well is that we need to be an if condition, because sometimes the message contains spaces. So what we can do here is that we can do if, sorry, here, we want, yeah, we want to do that. We want to do here. So we want to do here, we want to do if character is a capital, because this one here, what we want to do is we want to avoid, want to pass the spaces. Then so we're gonna do that one. If it's non-alphabetical letters, what we're going to do is we're just going to ignore them, and we're just gonna add them. So else set encrypt message equals encrypted message plus chat. So we're not gonna process them at all. So that is how you encrypt the message, and that is how you do in pseudocode. I know it's a lot. Hopefully, you can understand the concept. So now, let's go into the next phase, decryption. So if you want to decrypt the message, so let's just bring back here. Now we're just gonna adjust MQTT. Still the same concept, but what's different now is that when you are decrypting, you are actually minusing instead of plusing. So basically means now what we want to do is we want to minus A. So this one here we want to minus by 5. So we go by 5. How can we go back that? 1, 2, 3, 4. Because we want to count backward, right? So if we go M, it should align with H. No, that's not right. All right, give me 1 second. Let me think about it. Okay, wrong. So we have to minus by 5. So we actually need to shift this to the right by 5. So 1, 2, 3, 4, 5. So we're shifting this to the right. So that means if we want to test it, M and H should align. And then in here, we have to move it like this. Yeah, so we shift it like that. So this one here will be 25, 4, 23, 22. So how the calculation is going to work, right? So let's delete one. Nope, I still want to keep this. The calculation will be a little bit trickier because we're now going back to the left. So let's do index of M, which is equal 12, right? And then we minus the offset. So 12 offset, which is 5, which will give us 7. So that's 5. So that one goes to 7. And then we got character at 7 is H. So that's how it works. Right? So we got H. So this one here is simple. So you got H, E, L, L, O. So that's how it works. So that's why if you use this part here, it's a lot easier because you can do it manually. Now let's do the XYZ. So the XYZ will be very interesting because now we can go C. So you can go index of C, which is then equals to be 2, right? And then you have 2 minus 5. That one will actually give you minus 3. Because why? Why it's minus 3? Because this goes all the way to the left, minus 3. So what we need to do in here is that we need to do minus 3. We need to add back the 26 because we are technically going back to the back of the alphabet. So that will now give us into 23. So 23, so you do character at 23, which is then will give us the letter X. So that's 23. So that's how you do XYZ. So the formula is similar, but to decipher the formula, you actually need to know. So you need to know the character index minus the offset. what we need to figure out here is that if it's less than 0, we need to add back the 26. So the formula to do this, you basically say the new index. So hang on, let's say current index minus shift. Then what we want to do in here, so we want to do that one minus shift. And then what we want to do is that we want to have a formula that will work for both left and right. So minus shift, and then what we want to do is we want to plus 26. And then we want to do modulus 26. Tricky, right? So how this is going to work? So this one here, you will have 7 minus 5 plus 26. So that one will give us 28, right? And then if you have 28 modulus 26, that one will give us 2. No, hang on. No, my bad. Sorry, not 12 minus 5, 7. 12. 12 minus 5 is 7 plus 26. That is, sorry, brain doesn't work. 12 minus 5 plus 26, 33. So that will give us 33. And then we have 33 modulus 26. So that one should give us 7. So technically, by using modulus, if your number is bigger than 26, the modulus will negate the 26 and still give you the number. But if your number is less than 26, it's also going to give you that as well. So let's set up another calculation here. So what we have in here is that if we have 2 minus 5 plus 26, that one will give you 23. Yep, 23. And then you have 23 modulus 26. Because you cannot divide 23 by 26, it will give you back 23. So that's how the formula that works. So now in the ASCII calculation, because A doesn't start with 0, it starts with 65. So in the formula, so this one here, your decryption formula, this one here is going to be a little bit trickier, but all we need to do on the decryption is that we just have to do character index minus index A, then we go minus the shift character, and then we just have to add the 26. That's how the decryption code works. So the code is exactly the same. It's just that how you move the character will be the question. So I hope that helps. I'm just gonna copy and paste in here. This is something that we can run. This is what the code will look like in JavaScript. So that is your encrypt. So we have some sort of formula and that one there. And then this is the code that you can have. Yeah, so this is just a quick code from Copilot. So you can follow them as well. So it's a bit long, half an hour, but hopefully it sort of helps you to understand this one. So now I just forgot something. Let's can I change the layout? Breaking the cipher. So the question that you have is that, well, what do we need to actually break the cipher? And this is actually, I learned about this in a game. So let's just do this. Let's see if I can make it work, right? So let's play. Let me just quickly. I need to copy this. The copy my keys. Now, so let's encrypt the message and then let's try to break it. Okay. Mhm. We're still gonna use the key 5 to encrypt the message. So my is okay. So let's encrypt that one. So my name is John. So M equals Y equals D, N equals S, A equals F, N equals R, E equals 4. Yeah, no. E equals J, I equals N, X equals double X, John, J equals O, O equals D, H equals M, and N equals S. Okay, so that is the message, right? So now how do we decrypt it without knowing the shift? Well, it is going to be a bit tricky, but the key that we normally use to try to crack the code is that we need to sort of make smart guesses, right? So generally, if you know that the message is going to be in English, this and this is your keyword. Because what word in English that has two characters, right? So like you have like am, I am, is, are, something along that line. And by knowing the keyword, you will be able to quickly break the code, right? So what you can do in here is that what they say about brute force, meaning that you just brute force it. So you just start with that one, okay? So if you do index 1, right? So if you do index 1 here, what will happen here is that, um, so if you do index 1, so M is actually L, right? So you don't have to do a lot. So you just have to do that one. M is L, and then, sorry, R. Sorry, we don't, wrong one. So R is Q. Hang on, let me check it. Yep, the method is correct. So now we try to brute force this with index 1. So we got R here equals L because you got R. No, my bad. We have R here is actually Q. So that one's linking up to Q. And then we have D here linking up to C, right? And then we just have to worry about this one, N linking up to M, and then X linking up to W. So immediately we can say, well, that doesn't make sense. So now let's move on. So let's go brute force it again, index number 2. So index number 2, so R equals P, D equals B, and then N equals L, and then X equals V. So that doesn't work as well. So now we're gonna just gonna skip it a little bit more because you know what's gonna happen. So we brute force 4. So 4, and then don't forget the tail N here. So let's bring the tail back. So 4, so we got R equals N, and then we go D, go all the way back. So D is Z, and then we go I is E, sorry, N is J, and then we got X is T. So that is not right. So now we go and then we brute force this one here for index number 5. Index number 5. So now you're going to have M D equals Y. And then once you identify these two keywords, then you can then double check everything else. And that is how it works. Now inside the code, why that's why people say this is the weakest one, because you only have 26 different combination, right? So what you just need to do is that you just have to decrypt the code 26 times, and then you just have to look at which one is readable. And that is how you brute force the cipher, the shift cipher, to get the message. And this is something that I used to play in the game. So in the game we have this like a encryption method. So we have to make a guess, and how we play with it, we just have to identify the keyword that we think will be good, and then we can make it work. Now, an interesting fact: this is how the Americans is able to break the Enigma code, because the Enigma code is very, very difficult to break. However, what they found out at the end of every message, just because of the habit of those people, at the end of every message, they always have a keyword. And when the Americans realize that keyword, then very easy for them to know which message that has been properly decrypted. And the keyword is Hail Hitler. So once they find the last word of the letters Hail Hitler, then that means the code has been fully decrypted. So I hope this will help you to understand about the Shift Cipher. Um, so we covered a lot. We covered about the methodology. We covered about the pseudocode on how to do it, especially the mathematical calculation. Um, Hopefully that doesn't confuse you. What we can do with the mathematical calculation is that if this long formula is not working, you can actually break it down into simpler formula as well, right? So what I mean by that is that in here, so instead of doing that, right? So instead of that, what we can do here is that we can say we can do start position, start index. We can do the char index minus index A. So this one here, we basically setting the letter A to be equal 0, and then we go shift index equals start index plus shift. So that one here, basically you're adding 5. So you got 0 plus 5 equals 5, right? And then you go uh, to overflow index, for example, equals shift index modulus 26. So this one here is for protection, so that, for example, if you got 24, 24 plus 5, that equals 20, 29. So you modulus by 26. So, and that will equal 3. So that's what we do it here, right? So now you do an index. So you do encryption index or an index equals overflow index plus index A. And what that will do is that will do the 3 plus 65, which then equals to 68, which is the index of C. No, no, 3. So index of D. So break it apart. Don't have to do the code in one large sentence like that. Break apart the code so that, especially calculations, so that you understand how it works and how it flows, and put some numbers next to it so that you can sort of visualize how the code should work. Right. So that is the Shift Cipher or Caesar Cipher. Hopefully, I didn't burn out your brain for this. Good luck.